at this question. Find the particular solution of the differential equation dy dx equals x times y divided by x squared plus 1, given the initial condition y of the square root of 3 equals 6. Okay, this certainly looks separable to me. So I'm going to move the dx over here and leave it with the x's. This is going to be an interesting one. And then I'm going to divide both sides by y, so I have dy divided by y. Alrighty. I've separated my x's and my y's. I'm now going to take the integral of each side, taking the integral of the left side with respect to with respect to y, and the right side with respect to x. Okay, this part is not that bad. We know this is the natural log of the absolute value of y. This one, I think I'm going to do a little u sub for this. I'm going to do a little u substitution just to help me. So let's see, I'm going to let u equal x squared plus 1, which means du is going to be 2x dx. Let's see how that helps. So I've got x squared plus 1 taken care of. I have the dx taken care of. I have the x taken care of, but I have that extra 2 that I don't want. So let's just divide by 2. Alrighty, so now I'm ready to roll. So this right here is going to become my u, and I'm transferring to u land. This x dx is going to be replaced with 1/2. I'm just going to put the 1/2 out front because it's a constant. You don't have to do that, but you can. Okay, so now let's see. That's going to be another natural log. So 1/2 times the natural log of the absolute value of u plus c. Okay, let's put that back in x land, since this is an indefinite integral and I want my function to be in terms of x. So I have x squared plus 1 plus c. All right, now the question is, how do we best go about solving for y? Well, you can always remember there's a little invisible e as a base. So I'm just going to rewrite my log thing into exponential form. So it's e raised to this whole business, e raised to the 1/2, the natural log of x squared plus 1 plus c. That's all on the exponent, equals the absolute value of y. Let's keep going. We know that in this situation we tend to separate. I've talked about this before. I'm going to rewrite this as e to this times e to the c. We've talked about this before, right? When the bases are the same, you would be adding the exponents. So if I'm multiplying those two, you could rewrite it this way. This just makes this easier because now I can call e to the c. E is 2.718, blah, blah, blah. E raised to the c is just some other constant. Let's just scoot this up. So now I have some arbitrary constant times e to this whole brouhaha. And you know what? I'm just going to dispense with the absolute values here because I know that's going to be positive. I'm squaring something and adding 1. And I can get rid of the absolute values here. Technically, I would put a plus or minus. Remember, whenever you get rid of absolute values, you put a plus or minus there. But the arbitrary constant can absorb that plus or minus. All right. Let's look at this piece right here, because I can simplify that. But we might have to remember some of our log rules. So let's just remember some of our log rules. First of all, if I have a number in front of something, right? Remember, that's the same as the natural log of x squared. Okay, so this 1/2 right here, I can think of that as an exponent. Natural log of x squared plus 1 to the 1/2. All right, the other log rule we have to remember is this. It's not really a log rule. It's just the nature of what happens when you have two functions that are inverses of each other. If you recall, these are inverses of each other. And inverses undo what a function does. So e to the x, natural log of x, they're inverses of each other. So for that reason, if I put, let's say, natural log of e to the 3, well, e to the 3 is undone by the natural log, and so that gives me a 3. They undo each other. If I have e to the natural log of 3, well, the natural log of 3 does something to the natural log does something to the 3, and then the e undoes that. That also equals 3. So remember, whenever you do a composition of a function inside of its inverse, whatever your original input was, that's going to be your output. So, what does that mean here? That means that I can rewrite this whole term right here. This c is just hanging out. This is e to the natural log of something. Well, that's just the something. The e and the natural log undo each other. And there is your general solution. Does that make sense? Okay, so now I have to find my specific solution given my initial condition. My initial condition was right up here. So let me rewrite it down here. I hope you can see this. My initial condition was y of the square root of 3 equals 6. In other words, when my x is square root of 3, my y is 6. So I'm just going to now use this information to find my c. So I'm substituting in square root of 3 for my x. And I'm substituting in a 6 for my y. Square root of 3 squared is 3. 3 plus 1 is 4. 4 to the 1/2. Well, that's the square root of 4. So that's a 2. And that gives me a c of 3. Well, that's pretty cool. So now my particular solution is going to be y equals 3 times x squared plus 1 to the 1/2. Pretty cool. All right, I hope that was helpful.
Southbound again. Don't know if I'm